Hello, in this video I'm going to talk about how to sketch cubic curves of the form y equals ax cubed plus bx squared plus cx plus d. When working with quadratics, one will have gotten very used to sketching graphs of this form, a standard parabola such as this, or it may look something like this, or something like this, or it could be downward facing parabola, and so on. Well, working with cubics, it's very similar. You know, when you're sketching a quadratic, say something like this, you're going to find the two solutions, the two roots, by way of factorization, or using the quadratic formula, completing the square, so on, and you can also find the y value and so on and so forth. Well, dealing with cubics is quite similar, I suppose. And so, for example, say that we are given that y equals x minus 3 times x minus 2 times x plus 1. Okay, and we are asked to sketch the following curve and indicate clearly the points of intersection with the axes. Really, our x values are given here, our roots, and of course at this point we're only dealing with real roots and not imaginary roots. But so if we just set this to equal 0, we know that x is going to equal 3, right? Equals 3. It's going to equal 2. It's going to equal -1. Those are our three roots, and now we can just set x to equal 0, and we will find our value for y. So when x equals 0, y equals, and I'll just do the work over here. When x is 0, we have 0 minus 3 times 0 minus 2 times 0 plus 1. Well, that's just -3. 0 minus 0 minus 2 is just -2, and that's of course just 1, and so -3 times -2 is positive 6, times 1 is just 6, so we know that when x is 0, y is 6. I'm just going to erase this to save space. And the next thing that we want to do is check what happens to y for very large positive and negative values of x. This will help us understand what direction, it will help us sketch our graph, understanding what direction we're coming from. If that doesn't make sense, let's just, actually I'll draw it more like this. Okay, and say this is -1. We have here, say that's 2, and that's 3, and I'm just going to extend this a little bit. Oops, just a little bit. Say up here it's 6, okay, and that's the y-axis, like so, and of course that's the origin. So what we want to do again is we want to see what happens to y for very large positive and negative values of x. In other words, when x approaches infinity, y tends to, and really we can just use something reasonable in this case, say 10. So we'll just set all x values to 10 and see what happens. So we have 10 minus 3, 10 minus 2 times 10 plus 1. Well, 10 minus 3 is 7, 10 minus 2 is 8, 7 times 8 is 56, this is 11, 56 times 11, 56 times 11, 6 times 1 is 6, 5 times 1 is 5, 0, 6 times 1, 5 times 1, it's going to be 616, I think. That's 11, 1, yeah, 616. So just erase this. And so that's a pretty large value for x, and what that indicates is that y is increasing as x increases, and that's the key piece of information. So as x tends toward infinity, y also tends toward infinity. Now what about when x tends toward negative infinity? In other words, when it gets increasingly negative, what happens to y? Well, again, we'll just use a reasonable value in this case. We'll just set everything to -10. So we've got negative 10 minus 3 times negative 10. Whoops. Negative 10 minus 2, negative 10 plus 1. And that's going to be negative 13, that's going to be negative 12, and that's going to be negative 9. Well, negative 13 times 12, well, 3 times 2 is 6, 1 times 2 is 1, got our 0, that's 3, that's 1, it's 6, it's going to be negative 146. Okay, so, and then actually we have to multiply that by 9 still, and it's going to be positive 46, sorry, because it's two negatives being multiplied with one another. And so now we're multiplying it by negative 9, and 6 times 9 is 54. Carry over the 5. 4 times 9 is 36. 36 plus 5 is 41. Carry over the 4. 1 times 9, of course, is 9. Plus 4 is 13. So 146 times 9 is going to give us 1314, and that's negative. So what that tells us is that when x, and I'm just going to erase this for the sake of saving space, when x gets increasingly negative, y also gets increasingly negative. And the reason why that is valuable when sketching a cubic like this is that we know we're coming from this direction, we're coming up from this direction, because we know that it's going to be negative. Okay, and this is just, of course, just a sketch. So it's going to, we know our y-intercept is 6. Actually, for the sake of having this somewhat to scale, let's just say, bring it down a little bit. So it's going to come up from here, from the negative end, from the bottom. It's going to go all the way up. Okay, and we'll say that that's 6. And then it's going to come right back down, and we have roots at 2 and 3. So it's going to come down and cross at 2, and it's going to come back up and cross at 3, and then it's just going to go up. Okay, and that's our cubic. Let's work on another example. Say, for instance, we are given that y equals, say we are given y equals x times x minus 2 times x plus 1. Something a little bit different. So really, again, what we can see here is that when all of this is set to equal 0, x is going to equal either 0, 2, negative 1, or I can write it more appropriately, negative 1, 0, 2. When x is 0, y is going to equal 0, right? Because if this gets set to 0, then this whole thing is going to be 0. So we know that there's a root right here. It says it's 0, but it's going to be at the origin. Y, our y-intercept is at the origin. Now we just need to again find what happens when x tends toward infinity. What is y going to do? Well, we can just again use an arbitrary number, something reasonable, say 10. So we'll set x to 10. So it's going to be 10 times, 10 minus 2 times 10 plus 1. Well, that will be 8. That will be 11. 10 times 8 is 180. 180 times 11 is 180 times 11. I should know this. 180 times 11. That's 0. That's 8. That's 1. Bring this down. That's 0. That's 8. That's 1. It's 0, 8, 9, 1980. Okay, so just erase all of this. So 1980. So what's clear is that y is also getting much larger as x gets larger, and so if we just draw our axes here, negative 1 and 2. So just say something like that. Say that's negative 1. That's the origin at 0, 1, that's 2. versus 0, that's the x-axis, that's the y-axis. So when x gets increasingly large, y is also going to get increasingly large. We just found that. When x gets increasingly negative, y is going to get, well, let's find out. It's negative, we'll use 10, again, just an arbitrary number. 10 times negative 10 minus 2 times negative 10 plus 1. And you may already be able to predict what's going to happen here just by evaluating the signs, but this is negative 12 and this is negative 9. Negative 10 times negative 12, well, 10 times 12 is 120, and these are both negative, so it's positive 120. 120 times 9, and that's a negative 9, of course. Well, 0 times 9, 0. 2 times 9 is 18. Carry over the 1 times 9, so it's going to be 1080. And I should have known that from the unit circle, but nevertheless. Okay, so negative 1080. So when x gets increasingly small, y is also going to get, or when x gets increasingly negative, y is also going to get increasingly negative. So we're coming from this direction, down and up, and we've got our roots at negative 1. So we can sketch our graph like this. We know we have our root at 0. It's our y-intercept as well. So it's going to come back down, and then we have a root at 2. So it's going to come up like that. Right, I'll do one last example here, and then in the next video I'll work on a few more problems that are at least a little bit more challenging. So say, let's look at something different. Say we have y equals x minus 2 times 2x minus 1 times 2x plus 1. Right, well, I mean, the first thing to recognize here is that we just need to set this all to equal 0. We can solve for x already. And so x is going to equal 2. X is going to equal 1/2. And it's going to equal negative 1/2 as well. And now when x equals 0, if we set x equals 0, y is going to equal, well, if we just say that this is 0, and if this is 0, and this is 0, well, this is just going to cancel out, and that is also going to cancel out. So we have negative 2 times negative 1, that's just 2 times 1 is 2. So y is going to, our y-intercept will be 2. And now finally we just need to again find out, we need to see what happens to y for very large and negative values of x. Again, I will just use 10, just an arbitrary number that's somewhat reasonable in this context. So when x gets increasingly positive as it tends toward infinity, y is going to, well, we have 10 minus 2, 2 times 10 minus 1, we have 2 times 10 plus 1, 10 minus 2 is 8, 2 times 10 is 20, minus 1 is 19, and 2 times 10 of course is 20, plus 1 is 21. 8 times 19, that's going to be 9 times 8, and the one it's going to be 152. But I don't know this one, so 152 times 21. We've got 2 times 1 is 2, 5 times 1 is 5, 1 times 1 is 1, 2 times 2, 2 times 2 is 4, 5 times 2 is 10, carry over the 1, 1 times 2 is 2, that's 3, so we have 2, that's 9, that's 1, that's 3, so 152 times 21 is indeed 3192. Okay, 3192, so and that's positive as well, mind you, which is important to note. And so what's clear here is that as x approaches increasingly positive values, it gets larger, y is also going to tend toward positive infinity. Now when x tends toward negative infinity, when it gets increasingly negative, what is y going to do? So I'll just use again, I'll use negative 10. minus 2 times 2 times negative 10 minus 1 times 2 times negative 10 plus 1. I'm trying to do this in my head as we go to speed things up a little bit. Well, we know this is going to be negative 12. We know that this is going to be negative 20, and that's going to be, we're going to subtract, or again another negative 1, so it's going to be negative 21. And here we've got negative 20 again. We're adding 1, that's going to be negative 19. And you can see that already this is going to be a negative number, right? Because 12 times 21, that's going to, I don't know that off the top of my head here. Let's just look. That's 2, that's 4, 0, 1, 2, 2, 5, 2, so 252, and that's going to be positive. And then when we multiply it by another negative number, which in this case would be 20, it's going to be negative. So I'm not going to work that out for the sake of saving time. We just know that y is going to also be negative. So now we can just sketch our graph really, and we have roots at 2 and negative 1/2. So actually I can draw it this way. Let's just say that that is negative 1/2. That is our origin, so the x-axis, this is the y-axis. We have a y-intercept at 2, we have another x-intercept at 1/2 and at 2, and we know that it's coming from this direction, because it's y is going to be increasingly negative as x is increasingly negative, so it's going to come up like this. It's going to cross at y equals 2, it's going to come right back down, cross out our other roots of x equals 1/2, it's going to come back, cross at 2, and just go up, something like